Hello everyone, today we are going to learn about dynamic consolidation construction. The main contents of this section include the following points. 1. The definition of dynamic consolidation, ground improvement. 2. The construction process and key points of dynamic consolidation. Here, let's review the knowledge points we studied earlier. Do you still remember the methods of ground improvement? Yes, dynamic consolidation is one of them. First, let's understand the definition of dynamic consolidation. Dynamic consolidation is a method where a heavy temper is lifted by a crane to a height of 630 meters and then released to fall freely. The strong impact energy acts on the soil, generating shock waves and high impact stresses, forcing the soil pores to compress. Some soil may liquefy locally, forming cracks around the impact point, creating drainage channels that allow pore water and gas to dissipate. Soil particles rearrange, and over time, the soil consolidates and compacts. This improves the bearing capacity of the foundation and reduces its compressibility. It is one of the most effective, widely used, and economical deep ground treatment methods in China. Now, let us consider the mechanism and characteristics. In a very short period of time, dynamic consolidation applies a great amount of energy to the soil, which leads to physical changes such as the breakdown of soil structure, liquefaction, drainage and consolidation, and even thixotropy recovery. The final effect is that the strength of the soil within a certain range is improved, pores are compressed, and collapsibility is eliminated. Second characteristics. It uses simple and common equipment. The construction process is easy to operate. It is suitable for many soil types. The reinforcement effect is remarkable. Settlement after construction is small. The work efficiency is high. The speed of construction is fast. Raw material consumption is saved, and the cost is relatively low. As for its scope of application, dynamic consolidation is suitable for gravel soils, sandy soils, silty soils with low saturation, clay, collapsible loess, high fills, miscellaneous fills, reclamation grounds, and industrial waste or refuse grounds. It can also be used to prevent liquefaction of silt and fine sand, and to eliminate or reduce the collapsibility of large pore soils. Even for highly saturated sludge, soft clay, or peat, if appropriate measures are taken, this method can still be applied, and in some cases, it can also be used underwater. However, it should not be used where vibration may affect nearby buildings or equipment. In such cases, protective or isolation measures are required. The construction procedure is as follows. 1. Clear and level the site. 2. Mark the positions of tamping points and measure the elevation. 3. Position the crane. Align the temper with the tamping point. 4. Measure the elevation of the temper before dropping. 5. Lift the temper to the designed height and let it fall freely. Then measure the elevation after impact. 6. Repeat tamping until the specified number of blows and criteria are reached for each point. 7. Repeat the above process. Complete the first pass of all tamping points. 8. Backfill and level tamping pits with a bulldozer. Measure elevation. 9. After the specified time interval, Repeat for subsequent passes. Complete all rounds of tamping one by one. Finally, apply a low-energy finishing pass to compact the surface soil. Then measure the final elevation. During the construction process, there are several important points that we must pay attention to. These construction points are crucial, and you need to focus on them carefully. First, a proper geological investigation of the site must be carried out. For non-uniform soil layers, more boreholes and in situ tests are needed in order to fully understand the soil conditions. This serves as the basis for preparing the dynamic consolidation scheme and for comparing the reinforcement effects before and after tamping. When necessary, trial tamping should be conducted on-site to determine the construction parameters. At the same time, it is essential to identify the positions and elevations of underground structures and pipelines within the tamping range and take necessary protective measures to avoid damage during the tamping process. Second, before tamping begins, the ground surface should be leveled and the drainage ditches should be arranged around the site. The tamping points should be set out accurately according to the layout. When the groundwater level is high, a 0.5 to 2 meter thick of medium to coarse sand, gravel, or crushed stone should be spread on the surface to prevent equipment sinking and to help dissipate the excess pore water pressure caused by tamping, alternatively lowering the groundwater level. Before tamping is also an option. Third, tamping should be carried out section by section, usually from the edges toward the center, as shown in the following figure. For factory sites, tamping can also be carried out row by row, with the crane moving in a straight line from one side to the other. After each round of tamping, the site should be leveled with a bulldozer. The points should be remarked, and then the next round of tamping can begin. The general sequence is to reinforce deep soil layers first, then middle layers, and finally the surface layer. After the final round of tamping, a full coverage tamping with low energy should be performed. If conditions permit, using a smaller tamper for surface compaction can achieve the best effect. Fourth, the backfill soil must be controlled within its optimal moisture content. It can be wetted by sprinkling water or through infiltration. Fifth, tamping parameters should strictly follow the results of trial tamping and design. The tamper should fall steadily. The tamping points must be accurate, and the water accumulated in the pits must be removed in time. If the moisture content at the pit bottom is too high, sand should be spread before tamping continues. After each tamping round, the pits should be filled with new soil or nearby soil and leveled before the next round of tamping. After completion of tamping, the foundation pit should be repaired and a concrete blinding layer should be poured to seal it. 6. For highly saturated silt, cohesive soil, and newly placed saturated fill, it is difficult to control the average settlement of the last two blows within the specified range. During dynamic consolidation, the following measures can be taken. Appropriately reduce the settlement per blow. Appropriately increase the difference in settlement between blows. Remove silt from the original soil. Excavate longitudinal and transverse blind drains to drain water from the soil and lay a 50-seam layer of sand-gravel mixture on the original soil to ensure water is expelled during dynamic consolidation. Additionally, backfill the tamping pit with coarse materials such as rubble, gravel, or slag to achieve displacement compaction. In this way, the soft soil at the pit bottom is squeezed outward, forming a composite foundation with gravel columns and the surrounding soil, which usually achieves significant reinforcement effects. 7th, during rainy season construction, drainage ditches and flood interception ditches should be arranged around the site to prevent rainwater from flowing inside. The fill should be slightly higher in the middle. The moisture content of soil must meet requirements, and the filling should be carried out in layers, with each layer leveled and compacted. A surface drainage slope of 1% to 2% should be maintained. After rain, accumulated water must be removed promptly. The muddy and softened surface soil should be cleared, and then compaction should be continued. Tamping pits after tamping must be leveled and compacted immediately so that they are slightly higher than the surrounding ground. 8th, in winter construction, frozen soil on the surface must be removed before tamping. The number of blows should be increased as appropriate, and when there is a hard crust, additional blows or higher tamping energy should be applied. 9th, proper monitoring and record keeping are required throughout the construction process. This includes checking the tamper weight and the drop height, verifying the tamping layout, checking the locations of tamping pits, recording the number of blows at each point, and the settlement of each blow, as well as keeping detailed records of all parameters and the construction conditions. These records serve as the basis for quality control. Let's review today's lesson. In this class, we discussed the construction process of dynamic consolidation. The key content that you need to master is the construction procedure and the important points to watch out for during dynamic consolidation. That concludes today's course. Goodbye.